What's up guys, Rob here from BreVITy, and in this video we're going to be solving the move zeros problem using the two-pointer algorithms. Welcome back to week 3, the continuation of two-pointer week. Glad to see you didn't give up. Are you enjoying this sort of a learning environment on YouTube and Discord? If so, do let us know in the comment section down below. Week 3 is going to be super exciting as we delve into more problems which use the two-pointer technique. If you haven't subscribed yet, be sure to subscribe to make sure you don't miss it. Now let's get straight to the problem statement on LeetCode. Thankfully, this time it's a pretty short one. Given an array nums, write a function to move all zeros to the end of the array while maintaining the relative order of the non-zero element. So for example, if this is the given input 0, 1, 0, 3, 12, then the output should be 1, 3, 12, 0, 0. Both the zeros have been moved to the end of the array and the relative order of 1, 3 and 12 has been maintained. So 1, 3, 12, 0, 0 is the only answer to this problem. You cannot return something like, for example, 3, 1, 12, 0, 0, since the relative order of 1 and 3 will not have been maintained. We should also note that we should do this in place without making a copy of the array, and you have to minimize the total number of operations. Now the second part is not a problem because that's what we at BreVITy aim to do. But the first part, this means we cannot create a separate array and just copy paste the non-zero elements to that array and then copy it back to the first array. We can't do that. We have to do it in O of 1 space basically. So let me show you the visual demonstration of this problem using a presentation. Since we are in two-pointer week, you know the drill. We are going to declare two pointers. In this case, the first one is called cur and the second one is called last non-zero. Now cur is going to be moving from the 0th index all the way to the end of the array. And in case it encounters a non-zero element, then it's going to do a swapping operation. And the last non-zero pointer will always point to the index where the non-zero element can be added. Alright, so both of these are basically used for a swapping procedure. Now you can ask a question, how do we know when to swap? That's easy. We have to keep incrementing cur until it reaches the end of the array as explained. And now there will be two cases. Let's say that cur points to 0. Okay, so if it points to an index where the element is 0, then you simply do nothing. You just increment cur. Whereas if cur points to an index which does not contain a 0, in that case we are going to swap the array elements of the two pointers, namely cur and last non-zero. After that is done, we are going to increment the last non-zero pointer. Okay. So let me show you a run through with the current example. So initially we are going to make both cur and last non-zero point to the 0th index. Now we can see that cur is pointing to an index which contains 0. So no swapping takes place. We increment cur. Now when we increment cur, we see that it's going to point to 1, which is a non-zero element. So what do? We swap 1 and 0 because that is where cur and last non-zero are currently pointing. So after swapping, we get an array 1, 0, 0, 3, 12. Now we know that every time swapping takes place, we need to increment the last non-zero pointer. So that too now points to 1. Next, we are going to increment cur. Now cur is pointing to 0. And what happens when we point to 0? We do nothing. So now we simply increment cur again. And now it's pointing to 3, which is a non-zero element. So swapping takes place. Now we are going to swap 0 and 3, which is the elements which last non-zero and cur are currently pointing to. So now we get 1, 3, 0, 0, 12. And what do we do next? We increment the last non-zero pointer. Easy, right? So what happens next? That's right, we increment cur. And it's again pointing to a non-zero element. So we are going to swap 0 and 12, which is where the pointers are currently pointing to. And then we increment the last non-zero pointer. And now what happens? Cur has reached the last element of the array, which is the terminating condition. So this is the array which we are going to output. And that's really easy, right? 2 pointers make everything really easy. Now let us code this on Leetcode. So the first thing we'll notice in Leetcode is that the return type of the function is void. That's because we should simply modify the array and not return anything. So the first thing I'm going to do is declare the 2 pointers. So we have cur, which is pointing to 0 initially, and we also have last non-0, which also is pointing to 0 initially. And now we'll have a for loop for cur equals 0, cur less than nums dot length, cur plus plus. So now what do we do? If nums of cur, it should not be equal to 0, right? Because if it is equal to 0, we are simply going to do nothing. So if it's not equal to 0, that's when the swapping takes place. So when it's not equal to 0, how do we usually swap two elements? Well, we use a temporary variable, right? So int temp is equal to nums of cur. And then nums of cur will be equal to nums of last non-0. And then nums of last non-0 is now going to point to temp. So now we have done a simple swapping procedure where we have swapped the elements which are present inside the indexes pointing towards cur and last non-0. Now we know that every time we do this, we should also increment the last non-0 pointer. So last non-0 is equal to 1. And that's it. There's literally a 6 or 7 lines program. Let's run it. We can see that we didn't get any compilation errors, so let me try submitting the code. Runtime of 0 milliseconds, faster than 100% of Java online solutions. That is pretty much the best solution you can get. So if we were talking about the time complexity of the solution, it's going to be O of n, where n is the length of the nums array, and the space complexity is, you know it, going to be O of 1, because we are only declaring 2 pointers which will take up constant space in memory. And that is the solution to this problem. This was Rob. You're watching BreVITy. Thank you and goodbye.